Hey everyone, this is question 10 of the 2020 Matric 1. And yeah, question says, in a certain country, 10-digit telephone numbers with the following format were introduced. Okay, so we got this little table here that gives us some information. It says format, area code, exchange number, and then number, exchange code, number. Number of digits, 3 digits, 3 digits, 4 digits. And there's some examples. Again, they say digits may be repeated. Okay, 10.1 says how many possible 10-digit telephone numbers could be formed. Okay, this is a really nice question. Let's start with 1 digit and let's expand from there. So let's say you only had 1 digit, and you can say how many possible numbers could that represent, right? So if I had 1 digit, that is this placeholder can go from 0 to 9, right? So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is 10. Therefore this is 10 digits, right? And if we did with 2, okay, that is 0, 0 to 99, which is 100, right? That is 100 numbers. Another way of writing this is 10 multiplied by 10, or 10 squared. And of course this is the same as just 10 multiplied by nothing, which is just the same as 10 to the 1. Okay, that represents all the numbers, or the amount of numbers, or telephone numbers that can be dialed. So, but now this question has 10-digit phone numbers. So if we continue this system, this will be 10, and that will be a lot of zeros to a lot of times, which is the same as 10 times 10, times 10. That will be 10 times, which is the same as 10 to the exponent 10. And this will be as your answer. Okay, 10.2. Certain restrictions were placed on the group of digits. Okay, so it says area code, that is our first 3 digits. It says must be 3 digits, and the first digit cannot be 0 or 1. Okay. Let's just work through all the rules or the restrictions. The exchange code, which is the second bit, the second 3 numbers, must be 3 numbers, and the first and second digits cannot be 0 or 1. Okay, that's very similar to the area code. It's just instead of it only be the first digit, it's the first and second digit. Okay, and then number, that's our third group. It says must be 4 digits, and the first digit must be 0 or 1. Okay, so 10.2.1 says how many valid 10-digit telephone numbers could be formed by applying the given restrictions. Okay, so let's start with our area code. Let's see, 3 digits, so that's 000 to 9999, and then the first digit cannot be 0 or 1. Okay, so we're working with 3 numbers here, 3 digits, and so that's everything from 000 to 999. This is a total number, it can be written as 10 to the 3. And now we have a restriction that says the first digit cannot be 0 or 1. So you can see the 0, 0. Like all those numbers, all the starting numbers from 000 to in order will go from 2199. So after this will be 2. So how we would restrict this, we would look at the first digit. So you can see this first digit continues from 2 onwards, right? So that means the second and third is the usual 10 digits, but the first digit is 10 minus 2, which is just 8. So another way of writing this, this will, where this is normally 10 multiplied by 10 multiplied by 10, it will instead be, because we're minusing the restriction here, would be 8 multiplied by 10 multiplied by 10, right? And I think this is how we will represent our AC or our area code. And then we'll do the same thing for our exchange code. So we've got right here exchange code, but in this one it has first and second cannot be. So using the same logic for this one, we're going to be 8 multiplied by 8 multiplied by 10, since there's no restriction on the third digit, and the first and second has the restriction where it can't be 0 and 1. Okay, now we have numbers. Let's call it num. So this time we have 4 digits. So it starts off as 10 to the 4, or 10 multiplied by 10 multiplied by 10 multiplied by 10. Okay, but there is a restriction on the first digit, so it can only be 0 or 1, which is 2. So this first digit over here becomes 2, because it can only be 0 or 1. So this is 2 multiplied by 10 multiplied by 10 multiplied by 10. Okay, and now back to our question. It says how many valid 10-digit numbers could be formed by applying this given restrictions. So what we'll do, we'll take our new representations and put them together. So and this one. So what would we call this? Number of valid telephone numbers. Okay, this is equal to our AC or area code. So that's 8 multiplied by 10 multiplied by 10. And then we have our exchange code, which is multiplied by 8 multiplied by 8 multiplied by 10 multiplied by our number, which is 2 multiplied by 10 multiplied by 10 multiplied by the last 10. And if you type all of this in your calculator, you're going to get a very big number of 1.024 times 10 to the 9. Okay, and that's your answer. So there was a slight restriction, so it went from 10 to the 10, which is a very big number, to a very big number but slightly less, of times 10 to the 9. Okay, and then last question, 10.22, determine the probability that any random chosen 10-digit number, telephone number, would be a valid phone number. So probability, with probability there's of course how you define probability. Probability is your desired outcome over all possible outcomes, right? That's it. If you have a coin, you flip your coin, you want one, it can only be heads or tails. So your desired outcomes is tails. That is 1 over all possible outcomes, which is 2, since it's heads or tails. Now in this case, our probability is desired outcomes, which is a valid phone number, which we happen to calculate in our previous question. So that is number of valid phone numbers. All of this is all over. So that is what do we call this first answer? How many possible 10 digits? So let's call this 10 to the 10. And then this we have our answer here of 1.024 times 10 to the 9 divided by 10 to the 10. This you can type in your calculator. You can simplify this a little bit. So 10 to the 9 over 10 to the 10 is just 10 divided by 10. When you divide something by 10, you just move the decimal place forward, so it becomes 0.1024. So the probability is 0.124, which is, if you convert this to percentage, which equals to 10%, 10.24% to be exact. So the probability of calling a valid phone number is only 10%, which is extremely small. Which makes a lot of sense actually, because this number is just so big. So once you start making the restrictions, there's just a lot of numbers that you won't hit. And yeah, that's question 10. Hope you guys enjoyed, and I'll see you in the next one.